may be able to access after the workshop gets over.
Okay.
Hmm. Let me run a quick check. If I'm audible to all the attendees, kindly raise your hands, please. Okay. I don't think there must be some background noises. Okay, you can put your hands down. Thank you so much. Thank you so much for your assistance. Anton, in the meanwhile, can you please elaborate about the coding culture in Russia? I mean, I'm very curious to know because Russian community has its own name, which is written in golden words when it comes to hacking and other computer stuff. So, could you please elaborate what uh, I mean? Why why Russians are considered as a great computer enthusiasts?
Why Russians are computer and enthusiasts?
Yeah.
I don't know.
So how do you know any of your friend who is indulged in
I don't know. Who is involved in the computer science?
not computer science? I mean, obviously it would be computer science, but indulged in security. I mean, indulged in security applications like I can. I mean, like penetration or penetration tester. I mean to say, or someone who does red teaming.
Uh, not sure.
It's okay, no problem. I can understand even I've got such friends. I would I would avoid sharing. So we have got 9 attendees so far, and we are waiting for one more attendee to begin the workshop. Thank you all for your patience.
I think that we can start.
Yes, we will begin in a moment. Just give me 2 minutes only.
Okay.
Someone wants to ask something. Okay. So shall we begin, Anton?
I think yes.
Your voice is glitchy, although.
I think yes.
Okay, okay. So, very good afternoon to all the participants who are here. I hope that you all are having a good time with your family. My name is Asparsh Gupta. I'm an undergraduate student. I'm a Microsoft Learn ambassador. What brings me here is my love for computer science and my passion to share my knowledge with you all. I'm very glad to have you all in this workshop, and I will try my best to share as much as I can in the next 70 minutes or so. But before that, I want your help. And you can be kind enough to help me if you could keep your phones aside if possible. And trust me, at the end, it would worth it. We don't want any distractions so that we can soak up the best knowledge which we can acquire in the upcoming minutes. Over to you, Anton.
Am I audible?
Yes, you are audible.
Hello, everyone. My name is Anthony Kislakov, and I'm from Russia. I live in Moscow, and I studied at the Russian Technological University Mira, and I'm in my first year. I also participate in the Microsoft Learn Student Ambassador communities with cool events about chatbots. And today, I will tell you a little about the cloud platform Azure, and will show a small guide how to set up quickly chatbot and connect it with social networks using Azure services. First, thank you very much for inviting me to participate in this event. I need to say that from my point of view, I have problems with understand communication in English. So if you ask me, I guess I won't be able to answer your questions immediately, and I will ask you to repeat the question once again. And I have some problems with the internet connection. So if I'm lagging, tell me please about it, and I will repeat my last sentences.
Of course,
Spash,
Anton,
back
we
to
will
you.
be taking care of that. And if something gets missed out, we will be informing you. And we are. I apologize for that. You need to repeat again for our participants.
Thank you very much.
Yeah. So in this workshop, we are going to have a quick glance over natural language processing. Then we are going to talk about chatbots. Why chatbots? What are the types of chatbots? And then we will dive into the intellectually independent category of chatbots. Then we will talk about the working of a chatbot. What are the steps involved when a chatbot processes the user query? Then we will code the chatbot right now. I mean, in about 20 minutes from now. Then we will discuss the two machine learning algorithms, bag of words model and cosine similarity. Then Anton will guide you through the Azure bot services, which you can use to create a bot and to deploy it on your own website. So before diving into that,
Ash,
yeah,
could you please take the control of the presentation on your own? Ah, okay.
is it okay now?
Yes, perfect.
Okay. So before diving into our learning, I would like to lay emphasis on the different. I mean, how do we categorize AI, ML, and natural language processing? Most of the people are confused between AI and ML. I mean, they are not able to differentiate between what is AI and what is ML. So we must know that AI is a massive domain. It is basically the science which deals with the intelligence of machines. Whereas ML is its subdomain in which we try to make machines learn from experience. What I mean by experience is a pre-structured labeled data set which our computer can refer to and then predict the outcomes. In a quick manner, I would say that it is a more sort of probability with mathematics involved to give freedom to the computer to consider many affecting variables. Machines in machine learning, we try to teach the machine, we try to make it recognize patterns involved in the data. We feed some data into it and then we throw a very different piece of information and then we try to categorize it, and that's where the machine tries to recognize from the pre-processed data which we have already feeded into the machine. Every machine learning project involves a machine learning model, and we need to train that model. And that training requires a huge amount of data. The more you train your model, the more precise and the more accurate it will be. But we must avoid overfitting of our models. Sometimes we train our models too much that they are not able to properly categorize. I mean, they are very they become very restrictive to the user input. For example, if I train a machine learning model which recognizes images of cats and dogs, and if I did overfitting of my model, then my machine learning model maybe get confused if I throw some a random pic of a cat which looks kind of similar to a dog. That's the situation where a model is break. So somehow we shall not try to we are not going to train our model too much in this workshop. We will be covering only the basics and we will be training it only once, so that we can just have a quick idea of how does machine learning gets involved with chatbots. Whereas if I talk about natural language processing, so it is a subdomain of machine learning itself. And here we try to make computers understand our language. If I talk about our language, I'm not talking about Hindi or English or any other language, preferably. What I'm talking about is the human language. There are more than 2,000 languages which are spoken all over the world, and if I am not considering the regional languages, then 2,000 would be suffice. If I consider the regional languages, then this number may be very huge. So in to be precise, I'm just saying that NLP is the science uh, which helps computers and humans to interact with each other, and it makes very easy for the user to interact with the computer, because we all are in a habit of communicating within our own language. So let's proceed further. And I have talked about NLP and I have talked about its definition. So let's dive much deeper into our workshop. So there are over 30,000 chatbots on Facebook Messenger. Am I right? And more than 3 lakh chatbots on the Facebook, and 2 billion messages are being sent between people and businesses. And that's a data that data is being extracted from a survey which was conducted by a company named Digital Info. I don't remember the name. Pardon me. So we are only interested with what the survey resulted into. 56% of the people would rather message than call customer service. It is quite obvious because we all have an experience when we try to reach a Uber customer representative, and the page takes us to a chatbot. I mean, I don't think anyone of us has managed to call a customer representative of Uber so far. So that's another case that people prefer only to interact with the businesses via messages only. And another aspect of the survey is 53% of the people are more likely to shop businesses they can message. Yeah, that's something interesting. But does this require our consideration? I would say yes, because businesses tend to revolve around people only. And once we are close enough to the people, I mean, for example, if most of the businesses involve marketing on the social media. Just a second. Oh, I'm sorry. There was someone calling me. Anyways, so let's continue. So what I was saying is businesses are meant to be revolve around people only. So most of the businesses involve advertisement on social media platforms, and this is where the chatbots finds their usability. Most of the chatbots are deployed on some or other social media platform. I mean, you can find chatbots on Facebook or Instagram or any other social media platform you can imagine of. But I would like to draw your attention to one thing only. uh, NLP is not all about chatbots. I mean, natural language processing finds its implementation in chatbots, but it is not constrained to chatbots only. If I talk about natural language processing and its some of its implementation, so I can talk about the autocomplete feature, the auto correction, or I would say the smart search feature. I hope none of my participant is an old grandpa or grandma enjoying retirement by joining random workshops. So I assume that you all know what Google is. Even my grandmother knows it, but anyways, leave it. So I assume that we have used Google at least once, and we have seen the auto complete feature of the Google is pioneer in that, and it has the best NLP engine, I would say, which also finds its use in Google Translate. Google Translate also rely heavily on natural language processing. Another implementation which I can think of is the text to speech conversion, or vice versa. Chatbots, as we have discussed, they are which are being used mostly for the purpose of customer service automation. That's the technical term which we use to mention the use of chatbots. And the last example which I can think of right now would be, I guess, virtual assistants. Some great example of virtual assistants. I mean, you all are aware about them. One is Alexa. It has you have to install some skills into Alexa, and it can then help you to control music, manage alarms, or maybe she can help you in scrolling through the shopping lists. Another honorable mention would be Apple's Siri, a virtual assistant with a nice blend of speech recognition and natural language processing. Siri is amazing. I have used many times Siri on my friend's mobile, I would say iPhone, because I don't own one. And she works right out of the box without any work on your part, unlike Alexa, where you need to install some skills into it. Siri, as I told, Siri does not require any work from your side. And the more you use Siri, the better it will understand you, and that's what we call as personalization. Personalization is all about machines learning about you. We kind of predict the choices of our loved ones because we care for them. And that's why we remember their choices. Apple says Siri loves you too. Give Siri some time, and I think you all agree with me on that part, because as the time passes, Siri will learn about you, your choices, and it will predict more accurate. It will predict more accurately about your choices or your daily routine. Another another point which I apart from the workshop I would like to discuss is that there's always a probability whether one thing could happen or not. Things could eventually turn up the way they are not supposed to be. AI and machine learning are a hot topic nowadays, and expecting machines to talk in a humanly manner is still far beyond our reach. I'm sure you all have witnessed the products of virtual assistants from the tech giants, as I have discussed now, Alexa, Siri. So you can refer to them for the latest advancement in AI-powered chatbots. Why I am telling you this is uh, there's a long journey ahead. I mean, please keep your expectations a little low, because the chatbot which we are gonna make is not something would not be your best friend. I mean, it lacks the capability that it would be your best friend someday. And I'm not a tutor nor a data scientist by profession, so please pardon me if I speak something out of the blue. So I think we shall now begin with the working of chatbots. So far we have discussed why chatbots and what goes into the AI and ML, and what are some implementations. What are its some implementations? So let's define chatbots. A proper definition would be appreciated always. So a chatbot is a service powered by the rules and sometimes artificial intelligence that we may interact with, and it may have a chat interface or it may have a voice interface. And or simply I would say these types of programs are created to stimulate how a person would behave as a conversational partner. Chatbots are typically used in dialogue systems for practical purposes, including customer service. As I told, this is the most this is the field where chatbots find its implementation the most. Or chatbots are also deployed when we are seeking for some information. For example, a survey. Chatbots are a good way to have surveys. Moving further, we can divide chatbots into three categories: rule-based chatbots, intellectually independent chatbots, and AI-powered chatbots. If I talk about the hierarchy, rule-based chatbots are the easiest one to deploy and to code. Intellectually independent chatbots somewhat require a little bit of machine learning and neural networks, whereas AI-powered chatbot they are very tough to code. They require a huge amount of data, and I would say it is beyond our reach to for my it is beyond my reach to code a AI-powered chatbot, because it requires a huge amount of data and huge amount of computational power. Can you think of a AI-powered chatbot or virtual assistant if you can quickly guess it? Sophia is the name, I guess, and we have all heard about it. So that kind of chatbot is AI powered. If I talk about rule based chatbots, so these are the most basic type of chatbots on the market today. These are they have a glorified decision tree hierarchy. I mean, similar to the automated phone menus we all interact with on our daily basis. These chatbots will instead of throwing I would say check boxes or choices to you, they will interact you with via text, and you have to answer only either a yes or no, or you have to press a button or no. These rule based chatbots are used by many of the I would say IT companies, so that they can differentiate and filter the IT requests. For example, if I wanted to reach out a customer service representative and I'm interested in the products, I don't want any technical assistance. So I would reach out to their support page, and then I would be welcomed with a chatbot who would be answering me, who would be questioning me some questions about what problem I am facing, and then it will divert my call. It will filter me that I belong to the I'm my query belongs to the purchase section of the IT company, not to the service section. So that's where these rule-based chatbots find their implementation. Another one are intellectually independent chatbots. Uh, these chatbots, as I told you, are based on machine learning. This relies on training a neural network to think for itself by providing it with thousands or millions of examples. Intellectually independent chatbots, I would say, improve over time, and they are mostly used for entertainment and science. Intellectual independent chatbots do not find their use in the market section. I mean, they are not used for the purpose of, they are not deployed on the IT websites. You won't find any intellectual independent chatbot category on any of your uh, uh, any of your requested company site. The third category I would talk about will be AI powered chatbot. They are, I would say, a blend of rule based chatbots mixed with AI. And this bot has a predefined possible scenarios that can be interrupted at any moment. I mean, they have a very huge domain. AI powered chatbot can talk about anything, whereas intellectual independent chatbots and rule based chatbots are restricted to a single domain only. You cannot talk about anything to the above two mentioned category chatbots. So I guess that's enough for the explanation, and let's move to the coding part, I guess. Uh, and we will be for your curiosity, I will tell you that intellectually independent chatbots, and this is the category, and this would be the category of our chatbot which we are going to code right now. So a chatbot basically works on a messaging platform, and a chatbot has got chatbot has got a code and a knowledge base. Knowledge means that I would say it is the database on which our chatbot relies. We train our chatbot, and we categorize that information in the knowledge base category. So how does a chatbot works? Before coding into, we must think. We should think twice and code once. So once we know how a chatbot will work, then we can begin with the coding part. That accounts for only 2 slides only. So how does the chatbot processes a user's query? I would say. So the first step involves the conversion of the entire query into a uppercase or lowercase, because computers can't differentiate between a capital. Computers can differentiate between a capital letter and a small letter. They have different ASCII values associated with them. So in order to treat the data equally, we have to compare them with we, we have to compare them with another data set which we already have coded in our chatbot. So we must make the data comparable, and we do so by making it uppercase or lowercase. So that makes easy for the computer to work upon that feeded query. The second step would involve tokenization. We all know what tokens are. Tokens are the smallest individual bit of the data. For example, if I talk about this sentence, converting the normal text string into list of tokens, so I would say the token for this sentence would be the words, because it is the smallest unit by which this sentence has taken its shape. If I talk about this words, then the tokens will be the characters involved in this word converting. The third step, once we are done with the converting of the data into uppercase or lowercase, then we break it into a string of tokens, or I would say words. Then we move to the next step where the removal of noise takes place. What do we mean by noise? Is sometimes the user tries to elaborate too much, and the chatbot is not interested to have so many words involved in the query. For example, He is going to play basketball. So the chatbot is only interested with three words here: he, play, basketball, and the other words will be removed. This is called noise reduction, because chatbot is not considered with the other words. Because if I talk about a huge data set, for example, if I feed around 2 to 3 documents uh, for uh, for the purpose of machine learning to my chatbot, so that has too many words like is, am, are, or I would say that, this. So these kinds of words increase the data size, so we tend to avoid them. We don't use them in our data set. So that's why we need to filter those words out which has no meaning, which does not serve any purpose to our data. Same goes with the stop words. So noise reduction and stop words are somewhere similar. Noise reduction also involves the removal of, I would say, punctuation marks, for example, apostrophe, a colon, a semicolon, a comma, and full stop. These kinds of words, these kinds of symbols, which are of no use to the computer, are removed in the third and fourth step. The fifth step involves stemming. We all know we are good enough. We are good at grammar. For example, there's all I know. There's a difference between run and running. Running is continuous tense, and run is, I would say, present tense. Okay, but computers don't understand the grammar in that way that we are that we understand. So what computers do, they stem the word. I mean, they reduce the size of the word, and they dig until the base of the word is reached. For example, if I talk about running and run, the base word is run here. If I talk about planting, plantation, plants, so the base word would be plant here, right? So computer would uh, do the help us to reach the original word, the base word, which will then be processed further. And there comes the sixth step, which is known as lemmatization. What is lemmatization? Lemmatization is just a quick check that the stemmed word, I mean, for example, if I talk about flies, flies, so flies would be, I would say, another representation of the word fly. So flies, if I pass it through a stemming algorithm, so IES would be removed and FL would remain. Since FL is not a word in English language, so lemmatization finds its use there. So lemmatization would make that word match with an English dictionary word, which we are going to feed into and then we will have a well defined word. So by this process we make sure that we don't end up having non-existing words which has no meaning in the English language or any other language. Now the seventh step involves the comparison. So far we have only done the, I would say, the ear and eyes part of our chatbot, and the backs of words model is the brain of the chatbot. Here the machine learning finds its use. So we will be discussing about two algorithms. One would be the backs of words model, and another would be uh, cosine similarity. Don't think about these two algorithms too much. We will be discussing as we will be developing the chatbot. So I think I shall begin coding the chatbot, and we have enough of theory, I guess. I hope you all are still with me. Just raise your hands if you have any query so far. Okay, that's good. So let's begin with the coding part, I guess. Just give me a second. I'm switching my screen. This is taking long, but it doesn't matter. Just a second. Is my Chrome tab visible to you all? Just raise your hands.
Yes, it is.
Okay. So I would be using the Google Colab, a very good environment for using for creating projects that require machine learning and involves Python. Let's create a new notebook. So I mean, there can be a question: why Python? Why not any other language could be used? I mean, there, of course, you can use another language. You're not you're not restricted to use Python only. But why Python? Would anybody like to answer me? Can unmute himself or herself and answer that question. Why do we use Python for machine learning and artificial intelligence related work?
It has a lot of libraries.
Yes, that's the reason.
Easy
So
to
let me,
code.
from development to deployment and maintenance, Python helps developers to be productive and confident. How this is achieved? Because Python involves a very little code. For example, you all remember, I hope you all have an experience of coding in C, because C is the basic, I would say, the primary language of all the programmers. So if I wanted to print something on the screen, for example, if I wanted to print even a hello, so I would have went like this, and this is the code involved to print hello on the screen using C language. It includes a header file, a main function, a return type, etc., etc. But Python is a very clean language, and if you want to print something, you just simply use the print function and just type hello. Just a second, please. Excuse me, please. Actually, I've got some unavoidable interactions with people. Anyways, so let's continue. So what I was saying is Python involves a very little code to do something, and that's the beauty of Python. Other example, other feature could be that it has got a lot of frameworks for it. Machine learning and AI cannot, the largest libraries available for machine learning and AI is available for Python only. And it is very flexible language, platform independence, because it is an interpreted language like Java, and it has a very wide helpful community. So these add to the overall popularity of the language. So I'm going to discuss only a few key points before diving into the actual code of the chatbot. So this is how we print something using Python on the screen. Python also involves, as the same we have discussed in C, that that some data types like arrays or user defined data type in C++ like objects and classes. So everything is same with the Python. Nothing has changed so far. Python is purely a, I would say, an object oriented language. I mean, everything in Python is classes. Even this function, it is a part of a class. So I can say Python is a purely object oriented programming language. And two things which we are driving our concentration into. First is list. List is just a advanced version of arrays which we have discussed in C or C++ or Java. Lists are I would say a heterogeneous collection of data types. For example, in C we used to write something like this. For example, I want to declare an integer array of 10 integer variables of size 10. So I would use a declaration of like this, and it restricts me to involve any other data type. This integer would only be storing the integer data type in its array. So whereas in Python, I don't need to specify any data type. So I can, for example, write something like this. This is a list I'm creating. And in this list, I can append it and I can mention, for example, some of the car names, car brand names, for example, BMW, Audi, or any XYZ brand name. So this is a list in Python, and list is similar to as arrays, but it is more advanced in terms of its flexibility. In arrays, we are constrained to use only single data type, whereas in list, we can use different data type. For example, these three are strings in this list. I can append the fourth member in it, and it could be an integer, it could be a float, or it could be a Boolean data type. I mean, the true and false value. I hope you all are aware about the Boolean data type. So such kinds of data types, such heterogeneous collection of data types can be stored in a list. In the meanwhile, I can also talk about dictionaries in Python. Dictionaries are also similar to lists, but they involve another, different approach to store data in it. This involves the key value pair approach. For example, if I want to associate, anyone wants to speak something? No. And let's say another member of the dictionary could be another string, and I can map a integer to it. And if I want to access data, I want to access this dictionary, I would simply write a print function, and then I'll specify my dictionary name. And if I want to specifically point out to this integer value or this integer value, I can type the key name in it. For example, if I type the key Tushar in it, so my output would be Tushar. 34, the value associated with Tushar. So this is how Python finds most of its implementation. Although we are using different types of data type, you can see it has got strings, it has got integer, it has got float, it has got booleans. But we rarely use ambiguous data types. I mean, different data types we rarely use in a dictionary or list. So uh, if I encounter something which I need to explain, I'll pause for a second and I'll give consideration to it. So let's begin coding or chatbot. So before that, I would like to import some libraries into it. Libraries are just the same as we.
Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read.
Kindly mute yourself, please. Let me do it for you. Okay. So I muted everyone. So we are going to import some libraries. First is the input output library, which we are supposed to import, and it will help us for the fetching of the data. I mean, we are going to train our model, then we are required to supply it some kind of data to train the model. So we will be referring to the input output functions which are mentioned in the library IO. Another module would be random. Random helps, as the name suggests, random will help us to pick a random output when we want to greet our user. We will be seeing the functions used from these libraries as we code further. But for the time being, I'm just importing all the libraries. You can, in the meanwhile, type or I would say copy this code so that you can refer to after the workshop gets over. Another library would be string and warnings. Warnings are used because I don't want my program to interrupt if something goes wrong. So I would ignore all the warnings which I'll encounter by using the warnings module. And NumPy is quite famous library. I would say module because NumPy finds its implementation in almost all
भाई
AI and
तो ले
related projects.
हेलो हेलो
Hello. Yes.
Do you want to
ये
say
जो पढ़ा
something?
है हेलो हेलो
Yes, you are audible. Speak up.
हेलो हेलो क्या बकवास है हेलो
Then we would be
Okay,
importing NumPy.
continue.
Then we would be using sklearn library. That will be required for training our model. For the time being, don't think too much about the code involved. We will be discussing the code which we will be using from these libraries. Don't worry. And I'll be importing the TF-ID vectorizer. Okay. Another, I want to include the cosine similarity algorithm in my machine learning model, so I'll be importing that also. Cosine similarity.
हेलो
Anton, could you answer his query? He's very curious and I guess we are not audible to him.
हेलो
Hello.
हेलो
I
हेलो
will write to him. Maybe he doesn't hear us.
हेलो हेलो आर यू गेटिंग माय वॉइस हेलो
Okay, continue.
Hello Ritik, are you listening to us or not? Because you are audible, but I think you are not getting our voice. Anton, Sparsh is coming in a bit. He's plugging the charger.
Sparsh. Just a second.
Sparsh is coming in a bit.
Ah, okay.
Anton, Sparsh is having some network issue. You may continue the presentation. Hello,
The
Anton.
present.
I have not his part of the presentation. So, okay. I will talk about my part of the presentation. Just a second.
Actually, I'm really sorry. Actually, my computer when
You're here.
because Windows, thanks to Windows update, it started without any. It restarted without any warning. I really apologize for that. Please don't mind.
No problem. Continue.
Thank you. So I hope my screen is visible to you all.
Yes, it is.
So let's quickly finish the importing process for libraries. I guess that's enough. And let me turn off the warnings. Okay. So let me run it. Learn to skill SQL. We are installing some of the dependencies which may be required. I mean, I don't know whether it is configured on Google Colab, but if you are coding in your own ID on your own desktop, so this won't be a issue for you. But since we are performing um, okay, so that's great. Skll feature extraction, TFID vectorizer. Okay, so let's move on to the next code. Now we will be installing. Uh, we will be importing again some natural language toolkit library, and this library is already installed. So we don't need to perform a pip action on it. And I would be importing a lemmatizer. Lemmatizer, as we have discussed, is the process. Lemmatizing is the process when a word is converted into its root form. And I have discussed the example also. Okay, this code also works. Let's move on to the next part of our code. We need some downloads, I mean some resources from the NLTK library, which we will be downloading via this We have imported. Okay, now we will be downloading some of the resources, and we will use nltk.download. We will be using the category popular packages. I mean, it includes all the packages which we will be requiring for our chatbot to run. And we are downloading it from nltk. And once it finishes up, in the meanwhile we can code further. Okay, so the popular packages has been downloaded. Now we are supposed to upload the data on which our chatbot would rely. So uh, what uh, what do you want me to what do you want me to create a chatbot about? I mean, what our chatbot should be able to answer. For example, the data which we will be using for the training, the chatbot will answer questions about that topic or the data. So just comment in the chat box if you want me to train the chatbot on a special topic. I would be referring to its Wikipedia page. If you want me to refer to your preferred topics, then I would be considering that for the training data. So let's, if nobody wants to suggest me, so I would be referring to my own data set, which I will be creating right now. Is my screen visible?
Yes, it is.
Let's search for Pablo Escobar. And we will be using this much of data to train our chatbot. I'll create a new text document and let me refer to it as uh, training data. Let me paste it here, what I have copied from the Wikipedia. Let me make sure that my data does not contain any extra symbols. When we are deploying our chatbot in a real world scenario, I mean, you are using it for a business purpose, then you must train your chatbot with a huge amount of data. You cannot rely upon a chatbot who is trained using a Wikipedia web page, but we are doing so for the sake of explanation only. I'm not going to deploy it anywhere, and I'm very sure nobody wants to know who is Pablo Escobar via a chatbot. So that's why we are eliminating the choice of ours. I'm using this much of data to train my chatbot. I hope there are no extra words which should be avoided. So let's save this, and now I will be uploading it to my notebook. So in order to upload to my notebook, first let me share only the individual tab to you so that we can focus better. Okay, so in order to upload something from my computer, I would have to use a Google Colab library from google.colab, import files, and then we will be naming our files. For example, let it be uploaded, and we are going to upload our files. So I'll write the upload function. I'll refer to the upload function. I hope it is correct. Okay, so now we have a choice for a file. We are going to choose a file which we have created right now for our training data which we have created. So once it is finished, we will move further. Okay, so let's move further. Now we have uploaded the data. We need to open it in our program. We will use the open function. We will mention the name of a file, which I guess was training data. We will be opening it into the read mode, and then if it encounters any errors, we are going to ignore that. Now let's read that file and let's convert it into a lowercase, because as we have discussed, we need to, this is the first step involved in feeding data to a chatbot. So we have now converted our file into, okay, what's the matter? Is my, okay, I have to mention the extension of my file also, I guess. Okay, so now we are done with the part of converting. I mean, the first step has been completed. We have now successfully converted our training data into the lowercase. Now the second step involves tokenizing. I hope tokenizing, what is tokenizing, we have covered, so I won't go through the definition again. So first we will break into the sentences. I'll be using referring to the pre-built functions for tokenize, which is send tokenize, and we will just pass on the data. I mean, the file which we have opened and stored in this variable. And same goes with the word tokenizer. It will now further break into words. Okay, so this line converts all the list, I mean the data, into sentences, and this line of code will convert into a list of words. So this send token and send words are a list category, I mean list data type, in which we will be having members sentences. In this we will be having members words. I hope this runs. Okay, NLTK. So have we missed out NLTK somewhere? Okay, so let's move further. Now we are supposed to complete the, we have broken our text file into tokens. Now we are supposed to use a lematizer which we will be using from the library NLTK, and we will be defining two functions here. I hope you all know what functions are. I'm not supposed to tell you what are functions. So this function is gonna return uh, lematize for token in tokens. We'll be passing a list into it, and the list will be gonna stored in that tokens. Then we will be traversing through each list member via this for loop, and when it iterates through each member, that each member will be passed on this lematize method. Okay, this is a very simple function. It does not involve much code. Now we are supposed to remove punctuations, or I would say the stop words. We are now supposed to filter our code. I'll be very quick without wasting much time. So I guess this is enough, and let's move further. Now we will be calling another function which will normalize the text involved. We could have used the inbuilt functions directly, but giving it a name and according to our preferences, and sorting the data, I mean filtering on our own, also makes our task a little bit easier. Otherwise, if I could have also used a framework for that. There are libraries which already exist, which can help you to deploy a chatbot in merely 8 lines of code. But we are doing it our own so that we can we can regulate the flow of data into it. And our main purpose is to understand how does the chatbot works. Oh, I think I'm stuck with the spelling everywhere. Tizer, or there's something wrong with the spelling. Lematize for token and tokens. Okay. New function dictionary text order count known for single punctuation. Tokens what's tokenized text order text and another. What is this? Okay. Still we got an error. Let me see. Okay, I got a spelling wrong. Translate. Okay, so now that covers the lemmatization part. I mean the fourth process which we have discussed on how does the chatbot works. What it will do, it will remove the punctuations, and then it will take each word in consideration, and it will compare to the lemma which we have imported, the wordnet lemmatizer. It involves it includes an English dictionary. It will match each word with the English dictionary, and if it counts, it will return the word. Now let's configure the greeting part. I mean, we are only making the chatbot answer questions related to Pablo Escobar, which we have feeded the data into. So let's configure it, and this is called the hard coding of the chatbot, in which we specify what could be the user's query. For example, I'm typing this much. There could be 1,000 ways to greet a chatbot, but for the timing, let's consider that the user will be greeting the chatbot using these 5 strings only. And the responses which my chatbot will be making would be from a list. It could be a hi or a hey or hello. Hello could be there. Or what could be another greeting? I'm fine. Okay, that's it. Now let's define the greeting function. Sentence would be the query which the user will be typing to the chatbot. Then we will be traversing through each word, and we will be converting it into the lowercase so that we can compare with our greeting input. That makes it a little bit easier for the computer. And then if it found something in the which matches the greeting strings which we have passed, for example, if the user types WhatsApp, and if the computer surely will find that the string matched up in this greeting input, then it will return a random message, a random string from our greeting output. So this is called a hard coding of chatbots. So greeting output. Okay. So I guess I've finished with the hard coding of my chatbot, and sentence is there is spelling wrong. Okay, semicolon is missing. Colon is missing. Sorry. Okay. So now let's code the machine learning part, and this is where I require your attention a little bit. You can ignore it for a while, but we will be discussing the algorithms using the PowerPoint presentation. Just bear with me till I code it. We'll be having a user response as an argument passed in a response function. And let's say our chatbot chatbot response would be a string. Okay. Now we have defined send tokens in the code. We will be appending, we will be adding the user response in the send tokens. Then I would be using the IDF vectorizer function. We will be discussing it. Don't think too much about it, what it does. We'll be covering it soon. Let me finish with the coding part. Cosine similarity. Similarity. Then we will be passing first as an argument or data. Then we will be passing our user input. It will be comparing. Then we will be sorting it. So let's sort it. Um, let me run it. Let's define another variable so that we can refer to the chatbot output. TF-IDF. Chatbot. It found something in the. If it found something relevant, then it is supposed to answer. Else, it will answer simply, I don't know what you are asking. Response plus. I don't know what you are asking. Then we will return the chatbot response. Or else, if it found something which is relevant, then the chatbot response would be sent tokens list, send tokens dictionary with the response from chatbot as its output. Okay. So what is this cosine similarity and that TF-IDF vectorizer? So let's discuss it. Just give me a second. I'll switch it. Switch to my presentation. Just a second. Hinton, could you please share the PowerPoint presentation so that I can see it?
Excuse me, what?
I need to access the PowerPoint presentation. Could you please share it?
No. You share the presentation. You can't share the presentation.
Just a second. I was searching for it. I thought you got it on your desktop, so that's why I asked you. Doesn't matter. Is the presentation visible?
Yes. Visible. This is my part.
No, I don't want your part, brother. I want My part. Uh, Please pardon me just a second. I'm re-uploading the presentation so that I can refer to.
I'm trying to find it on WhatsApp.
Of course, of course, of course.
But I can't.
We are very end. I mean, we have coded almost everything about our chatbot. Now we are only required to code the main function. So please have some patience. Okay. So we have got two algorithms working here. One is bag of words, in which what we do, as we have filtered out everything and we have eliminated all the stop words and all the noises, then what we do that we keep a bunch, I mean a bag of words. You can refer to this image I've found this on internet, and this is a very good example. As you can see, this is a text snippet right over here. If you could keep it, if you just if you filter this out and you keep it in a bag of words, I mean a bag which is full of words, then the bag of words representation says that keep every word aside and either count the frequency of the words or just mark as absent or present by using 1 or 0. What I wanted to say is each sentence or document is represented here via a symbol, I mean an integer, because computer don't understand words. We need to use some another way of showing the presence of words in the data set. So that's why what we did, we filtered the data, then we kept in a single document, then we assigned similar to a histogram. We have already studied histogram in our earlier classes, so we assigned the number of frequencies it encounters each word. So you can see here we have used the number of frequencies as a measure. We can, as I told you, we can also use only zeros or ones if we want to refer to their presence. So after that TF IDF frequencies, see, word bag of words has a problem with it, because for example, suppose a document is of 1,000 words, and we all know that words like is and the, these are repeated very frequently. So the bag of words representation alone will give them too much priority. For example, consider this example, and we can see that the word it has 6 as its frequency. So somehow the preference, I mean the algorithm has decided to give preference to the word it, and we don't want that. So we came up with another method, which was term frequency inverse document frequency. This is TF-IDF. It is a very simple formula like this: log of documents upon documents containing the word W. Let's consider these a quick example. Consider these two documents, and suppose the document one is this is a beautiful day as its content, and document two as this is a beautiful night as its content. So if I count the frequency, so let me assign a random number to it. So this has been assigned 1, is has been assigned 1, beautiful has assigned 2, and day has assigned 5. Similarly, on the document 2, you can see, you can refer to the table. Now let's calculate the term frequency and inverse document frequency. So the word beautiful in the document 1 appears 2 times, so it's 2 by 10. Then its inverse document frequency would be documents. There are 2 documents, so documents upon document containing that word. So beautiful occurs 2 times here, and there are the number of documents are 2, so log 2 by 2, which is 1, and log 1 is equals to 0. So let's talk about the second word, I mean day. So the term frequency of day is 5 by 10, and the inverse day frequency is 0.30. So when we multiply it, I mean we multiply term frequency into inverse document frequency, we get 0 as our answer. And when we multiply the term frequency of day into its inverse document frequency, we got 0.15. So overall, word with high term frequency IDF means a signature word. So that lays more emphasis on what is that word. So this method correctly identifies that the word day has more significance than the word beautiful, right? So such kinds of algorithms were implemented after the bag of words was declared as obsolete. But some variations could be used, and it can still be implemented. So what we have done in our code is we have implemented the same, the term frequency in the TF-IDF vectorizer, which does this work for us. And and if we talk about the cosine similarity, so I found this article on the internet which was very relevant, so I just picked their snapshot. So what does that TF-IDF vector does is it creates a matrix like this. For example, we can consider these 3 documents over here, you can see on the screen. These are the Wikipedia pages of Sachin, famous cricketer Dhoni. Okay, and the third document is a small selection of that Wikipedia page of MS Dhoni. Then we passed it through the TF-IDF vectorizer. It created a matrix like this, right? Then we passed it into a similarity matrix. What does similarity matrix does is it finds the similarity between the documents. For example, we are going to ask something to the chatbot. Then the chatbot must determine what the user is asking and what should it fetch from the database. So that's why cosine similarity is used. And we can you can just refer to the graph here. I did nothing, I just plotted this table contents, table headings over here, and we can see the cosine distance between Sachin document and Dhoni's document is very large, whereas the small document, a small extract of the same document has a cosine angle very less. I could have also used Euclidean distance, but Euclidean distance, although it differs from Sachin's Wikipedia page to Dhoni's Wikipedia page, but it also differs. I mean, the difference between the document of the same cricketer also is very large. So in this case, we are forced to use the cosine distance algorithm rather than the Euclidean distance algorithm. So let me switch back to my uh, code window so that we can continue, we can finish coding our chatbot. So I hope my screen is visible. So let's try to run this. It has got some error. Cosine similarity. Okay. Okay, this works. Now we are only left with the coding part, which involves the which involves only the interaction part of the chatbot. We have coded chatbot and we have trained our chatbot in the above function, response function. Now let's code the main part. I mean the interactive part of our chatbot. So let's set a flag and let's run a while loop, because we want the user to keep interacting with us until and unless the user specifies that it doesn't want to access any more. So we will be taking the user input here. Then, as I told you, the first step involves converting it into a lowercase response. Now we will be comparing it with our exit word. I mean, in order to exit the conversation, the user would type exit or bye. I would prefer bye here rather than exit because to give it a more conversational look. Now, what I'll do is I'll code a little bit more to give my chatbot humanly behavior. For example, if the user doesn't says bye or says thank you, so the chatbot must know what he should be doing next. So it will return thank you. And then the flag, I mean, we are supposed to exit the while loop. So we will set the value of our flag false here, and by doing so, our chatbot will exit. And let's greet the user with you are welcome, and then we are finished with this part. And what if the user doesn't says bye, then we must compare the user's greeting once again. Here, concatenation of strings is going to take place. We will be differentiating our response from our chatbot response by assigning a chatbot tag every time the chatbot throws an output. So it will be easier for us to know who is interacting. I mean, is it was the message sent by me or from the chatbot? Or else I could do one thing. I could refer to this. I guess the spelling of chatbot is wrong. And let's end this with if the user response is empty, then the chatbot will greet. Okay, and if the is not empty, then the chatbot will greet the user. And if the user response is something else, then we are going to pass that into our response function, which we have created earlier. And this finishes our coding for the chatbot. We have finished with the chatbot part, I guess. We are about to run it. This completes, I guess, the whole part. Okay, this if block is still left. So let me, okay. So else flag is equals to false int chatbot bye. Let's run this, and I'm very hopeful I'll encounter some error. Okay, I got user response. Invalid syntax. If user response, I've defined user. User response. Let's try to run it. Flag is not defined. I now let's rerun the code. Filter warnings. So much of typing error. We have imported NLTK. From NLTK, we did this, and I hope we uploaded our training data, then we tokenized it. We imported a lemma from the lemma library. Then we coded the greeting part. Then we defined the user response. There are some spelling mistakes. Pardon me. Okay. Let me run it. Then we have just defined this flag part. Let me greet on the 14th line of the code. Okay, I've misspelled something, I guess. Pens. Okay, here. Rerun it. Rerun it. Still we got some error. Print user response. In the meanwhile, I'm looking into it. Anton, you may continue with your quickly cover up your Azure part. I'm transferring to you, Anton.
Okay, just a second. I can't present.
What happened?
I haven't got, but I haven't, but there is no button. Could
Just
you
shimmer
please
your
make
mouse
me
once and
a presenter?
you will be able to see that tab. May I open the PPT for you?
Yes, it would be great.
Just a second.
Okay.
Okay. So the file is uploading. Just 10-second more.
Okay. Okay. Am I audible? Am I audible?
Yes, you are audible. Continue, Anton.
Thank you. So let's begin. Deploying a chatbot using Microsoft Azure. So Microsoft Azure is a cloud platform that is widely used mainly in business. Such as working with cognitive technologies with databases, you can configure an unlimited number of servers and work with an unlimited number of databases. With bots that we will talk about, with AR, VR, MR services, with business and developer platform, DevOps, and, for example, convenient notification hub service, and others. I need to say that Asia the more resources you take, the more environment fares available, ranging from free limited resource usage to paid corporate fares. So you can choose any that suits you. Okay, let's talk about making chatbots in Asia. Note that I will give only theoretical knowledge, since the practical process actually takes an hour to configure chatbot using Asia. You'll be using Microsoft Bot Framework.
ఇదైతే ఇక్కడ యాత్రలో అంత ఇదిగా ఉందనుకో ఇదే వాడతారు అదే అదే
Second, I talked about configuring a chatbot using Asia. So you'll be using Microsoft Bot Framework. This is a platform for creating chatbots. You can read about it more on the internet, botframework.com. And Azure Bot Service. This is a cloud service built for the bot development, and it usually connects your bot with social network. We can call it just as engine or brain. So if you have Azure subscription, you're welcome to open Azure portal and find the button called as bot services. If you do not have subscription, you can use Azure for Students subscription, which gives $100. If I'm right, that you can spend. So let's return to the Azure portal. As I said, you need to open bot services. Then you need to add a new bot service in an easy way. You need to push the add button. Also on the screen, you can see a list of your other bots. Then you need to choose web app bot. If you choose web app bot and then push the create button. And fill the required fields. So you need to type a unique ID for your bot, then choose your subscription if you have a multiple choices. Choose your rated ones for one project. So if you are making a test bot or you are working on the project, it's better to create a new resource group. Also, choose the region where your data will be saved and stored. It's better to choose places nearby. Then choose the most suitable price. The app name will automatically be filled, and then you can choose the template. It can be an empty template if you are coding, for example, in Python. So you need to set up it manually, or you can use, for example, a C# template if you wish. Other settings are optional, and then you need to push the create button and wait. So you need to wait about a few minutes because waiting is such a tedious process. It requires some time to deploy, and then you can go to resource. You will see the start page in Asia with detailed instructions. What to do. Firstly, you can download the source code and download the emulator. However, there is no need to download because you can test your bot in the browser. So if you want to test your bot in the browser, you need to go to page test in web chat and test it there. Here you can see a screenshot of testing. If you want to connect your bot with different social networks, for example, with Telegram, Teams, Facebook, you need to go to channels page. So here you can see the status of each social network, and you can get connection. Connection process is unique for each social network, but for Telegram, this process is easier. You can read more about it on the internet. Also, as I told you, you can choose between price and plans. Just choose and press the select button. So you see two pricing plans: free plan and standard. Uh, to use Asia, you need to understand that it is the pay-as-you-go platform. So if you are not using chatbot, you need to turn off it or change price and plan manually. This design looks like the Visual Studio Code one. So if you want to test your bot, you can use either this emulator or Asia web page. I need to say that the principle of working with bots is as follows: plan, be and evaluate. And if the bot doesn't meet your requirements, expectations, go back to step 2. Also, you can create bots using AZURE in C#, JavaScript, Python, Java. The best variant, from my point of view, is C# because you can start working with your bot immediately without setting up anything else. Starting development, the process another. Here you can see the scheme of using the bot service. By the way, to create the perfect bot, you can use all the Azure services, implementing database, for example, perform analysis, and connect to the speech recognition service. So if you're interested about it, is not difficult. I advise you to use the Microsoft Learn service and open the instructions on docs.microsoft.com. Thank you for your attention and thank you for visiting our workshop. Spash, back to you. Spash, we don't hear you.
Sorry, I didn't notice my mic was off. I'm sorry.
No problem.
Is my screen visible?
Yes, it is visible.
So let's try that our chatbot works fine or not. Let's have a look. So we have coded only, I would say, not more than 80 lines so far. So let's see what we have achieved in the 80 lines of code. Let's greet it with hey. Okay, it replies with me hey. Let's try again and let's greet with the same word. Okay, so as you can see, the chatbot is using a random word. Chatbot is picking a random word from this greeting output file. But this is just an example of what a hard-coded chatbot looks like. But we have used machine learning to train our chatbot on the data set which we provided. I hope you remember the file that I have uploaded. I copied the text from the Wikipedia from the page of Pablo Escobar, and I have feeded it into the chatbot so that it can train. So let me ask a question related to that data. And if everything seems perfect and our model is, I hope, trained well, then the answer of this question would be somewhat relevant. Okay, so I guess the answer is relevant, and that is what we were aiming for. So this is how we code a chatbot in Python using NLTK libraries and some machine learning algorithms. If you want, I'll share you the code with you on the Telegram group if you have joined, or you can mail me personally if you want this code. And thank you so much. You all have been a lovely audience. Thank you so much for attending the workshop. You all can leave now.
If you have any questions, you can ask just now.
Yep, you can ask if you have any questions. Yes, there are. We will be dispatching the certificates by 17th, the night. Okay. You will be receiving your certificates by tomorrow, most probably by tomorrow. You're welcome, brother. Anything else? Anyone wants to ask anything? Go ahead.
Okay, thank you all. Splash, you can turn off the recording.
Yep, I have turned off the recording.